kids, Miss Block here, and today we're going to discuss igneous rocks. I recommend that you have your reference tables handy as well as your pink vocabulary sheet, like this one right here, with you as we go through. Again, as always, you can rewind and watch things over again or pause it to see if you need to look something up. You ready? Let's get started. So before we really dive into igneous rocks, we need to talk about minerals. And as you recall, minerals are solid, naturally occurring, inorganic items with a fixed composition. They're crystalline elements or compounds. Minerals happen to also be the building blocks of rocks. And rocks are solid, naturally forming substances that make up many landforms and various other features. We can classify rocks into three groups: igneous, sedimentary, and metamorphic. Now, unlike minerals, where we classify minerals based on their composition, such as silicates, they're made up of silicon and oxygen, rocks tend to be made up of many of the same minerals. So composition is only one feature that we could use when we're classifying our rocks. And we'd use that to maybe get more precise classifications. So instead, to classify these three groups, we divide them up by their method of formation or their origin. Today, we're going to look at the first rock ever, igneous rocks. Now, igneous rocks are rocks that form from the melting, cooling, and solidification of liquid rock, magma or lava. Now, there's a difference between magma and lava. We can't use them interchangeably. Magma is liquid rock beneath the Earth's surface, while lava is liquid rock on the Earth's surface. And this is going to come into play when we look at some of the different types of igneous rocks. Now, you can tell if you're looking at an igneous rock based on some very simple observable characteristics. This rock here on the left, you can see, is granite, and it has many intergrown crystals. So when that igneous rock formed, you can see that it crystallized, and the crystals grew into each other. On the right, we have an igneous rock that has a vesicular texture. This means that it cooled so rapidly, crystals didn't form, but air was actually trapped in here in the form of pockets. Now, as I said before, these are rocks that form from the melting, cooling, and solidification of liquid rock. You don't need to memorize this because you can find this on page 6 of your reference tables. So if you look right here, I've highlighted in this rectangle where igneous rocks can be formed, or found, I should say. And to make an igneous rock, again, the rock needs to melt. So a sedimentary rock can melt, a metamorphic rock can melt, and even an igneous rock can melt to form another igneous rock. But we can't just go directly to igneous rocks. We need to turn into magma or lava, that liquid rock. After we become that magma, we'll have solidification take place. And during solidification, we'll have crystallization. Because as it's solidifying, crystals will form, and so many crystals will start to bunch up and they solidify. We can see right here some of the differences between magma beneath the Earth's surface and lava at the top above. Now, depending where it is, will come, as I said earlier, will affect some of the characteristics. We call this intrusive and extrusive. So let's look at intrusive first. Intrusive igneous rocks, they're what we call is another name for plutonic, and they form from magma cooling underground. They have large crystals due to their slow cooling, and the texture of them will be coarse or very coarse. Now, when we talk about texture, we're not talking about how rough it is or how smooth it is. We're actually talking about how big or small the crystals are. So when we have something that's cooling very slowly, it gives more time for those crystals to form. So you can see right here are rocks with a coarse texture and a very coarse texture. So this is granite. This had a long time to cool, and the crystals grew into each other, and they're very visible. And you can see the different minerals that make up this piece of granite. Likewise, I have some pegmatite here, and this is very coarse. This had a real long time to cool, and these crystals are greater than 10 millimeters. Now, sometimes it can be extrusive. Another name for extrusive is volcanic. So this is what happens when lava cools above the ground. And they'll have really small crystals or no crystals due to their fast cooling. All right? They might even have something like a glassy texture or have a lot of a vesicular texture. They'll have a lot of those gas bubbles like we saw earlier. And the texture would be fine or glassy. So right here we can see our sample of rhyolite. That's a fine texture. You can see some crystals like right here and here. We have some obsidian here that has a glassy texture. And we also right here have a glassy texture with vesiculars. This picture just pretty much illustrates and reinforces what I said. Extrusive igneous rocks cool quickly above the surface right here from the lava. And right here we can see our intrusive right here, deep in the earth. So if we were going to make a graph of this, as we had more cooling time, what would happen to our crystal size? We'd have a direct relationship because as cooling time increases, crystal size increases. So if I put some of my igneous rocks on there, you can see cooled very quickly, glassy texture with vesiculars. We have right here some rhyolite with a fine texture. This is pumice, by the way. And right here, I have some granite, which has a coarse texture. Now let's talk about crystal size and cooling rate. So the rate or the speed at which it cools, what's going to happen to our crystal size? We're going to have an inverse relationship. So as cooling rate increases, crystal size decreases. So if it's cooling off rather quickly, it's going to be very, very small crystals or no crystals. And we can put our rocks back on here. So the crystal size here, very slow cooling, will have that coarse texture. Very quick cooling, we have that glassy texture with the vesiculars. We can find right here our method of environment of formation right at the top. So the rocks found at the top here, these will all have formed above the Earth's surface. They're extrusive or volcanic. So again, they'll be non-crystalline. Then we can get a little bit of a more finer texture. So here we'd have no crystals to small crystals. Some of them will be no vesiculars or have a vesicular texture, and you just read this across. At the bottom, we have the ones that formed below the Earth's surface with magma. These are our intrusive ones. These will have either a coarse or very coarse. Pegmatite is the only one here that would have a very coarse texture. We can also look at composition. Felsic igneous rocks are rich in silicon and aluminum. They tend to be light in color and low in density. So right here we have some examples of felsic igneous rocks. This one here is rhyolite, and here is granite, and you can see how light they are due to the minerals that are present. Okay, they have a lot of quartz in them that makes them light in color. Mafic igneous rocks are rich in iron and magnesium, and this causes them to have a dark color and have a high density. So right here I have some basalt and some gabbro, and we can see right here the dark color. We also know from when we did our lab that they're very dense. Okay. In addition, they have this because of the minerals present. They have olivine and pyroxene present that gives them that density and dark color. We can find the various composition this way. So you would look down. So right here, the rocks located on this side are felsic. They're rich in silicon and aluminum. They're lower in density and lighter in color. All right here. Okay. We can also see the minerals present in potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole. Quartz and potassium feldspar are found especially in these felsic rocks, as I highlighted right there. On this side, on the right, we can see our mafic rocks. Okay, and in this case, so we have salt, gabbro, and we can look right beneath, and you will see instead of having that quartz and potassium feldspar, we have pyroxene and olivine, which really contributes to having that higher density and darker color. These are the 4 most important igneous rocks I think you should be aware of because they really sum up what we've been talking about. So if we look right here, we have rhyolite, which would be our extrusive felsic igneous rock, light in color, low density, and it has a fine texture. So we can talk about composition and texture. Granite would be our felsic intrusive igneous rock. Again, light in color, low in density, but instead of having a fine texture, it has a coarse texture. Right here, I have basalt. Basalt is an extrusive mafic igneous rock, and this has a fine texture, but that mafic composition, which makes it have a high density and a dark color. And gabbro right here is an intrusive mafic rock. And we can see right here we have, the coarse texture, but very high density and dark color. I hope this was helpful. If you were stuck on anything, feel free to rewind this. And again, make sure you're looking at your vocabulary sheet and understanding which terms go with igneous rocks. I hope this helped you out. See you later. Bye-bye.